Taiwan Semiconductor Manufacturing Company, TSMC, has become the world's dominant semiconductor manufacturer due to a combination of strategic decisions, technological leadership, and favorable economic conditions. Here are the key reasons for its success. 1. Pure-play foundry model. TSMC pioneered the pure-play foundry model, meaning it only manufactures chips for other companies, like Apple, NVIDIA, AMD, and Qualcomm, without designing its own. This allowed fabless semiconductor companies, e.g., AMD, NVIDIA, to outsource production while focusing on design, fostering a thriving ecosystem. 2. Technological leadership. TSMC has consistently led in process node advancements, e.g., 7 nanometers, 5 nanometers, 3 nanometers, and now 2 nanometers development. It was the first to mass-produce EUV, extreme ultraviolet, lithography at scale, enabling smaller, more powerful chips. Competitors like Intel and Samsung have struggled to match TSMC's yield rates and performance efficiency. 3. Massive R&D and capital investment. TSMC invests $30 to $40 billion annually in R&D in new fabs, e.g., Arizona, Japan, and Taiwan expansions. Building cutting-edge fabs, like its gigafabs, requires extreme precision and economies of scale that few can match. 4. Strong customer relationships. TSMC works closely with Apple, NVIDIA, AMD, and Qualcomm, securing long-term contracts. Apple alone accounts for 25% of TSMC's revenue, ensuring stable demand. 5. Geopolitical and government support. Taiwan's government has historically supported semiconductor development, e.g., tax incentives, infrastructure. The CHIPS Act in the US and similar policies in Europe now incentivize TSMC's global expansion. 6. Manufacturing excellence and yield rates. TSMC's yield rates, percentage of usable chips per wafer, are industry-leading, reducing costs and improving efficiency. Competitors like Intel and Samsung have faced delays and yield issues, e.g., Intel's 10 nanometers struggles. 7. Economies of scale. TSMC controls over 55% of the global foundry market, 90% plus in advanced nodes below 7 nanometers. High volume allows it to spread R&D costs across many customers, lowering per-chip costs. 8. Limited competition. Only Samsung Foundry and Intel Foundry compete at the leading edge, but both lag in yield and scale. China's SMIC is restricted by US export controls, EUV bans, limiting its ability to catch up. 9. Future challenges. Despite dominance, TSMC faces geopolitical risks, China-Taiwan tensions, US-China tech war. Rising competition, Intel's foundry push, Samsung's aggressive roadmap. Cost inflation, next-gen nodes like 2 nanometers require even higher investments.